Hello everyone, welcome to our channel Higher Mathematics. In this video lecture, I am going to discuss next PYQ of Linear Algebra asked in CSIRNet 2023. So our question is, let A be a 3x3 matrix with real entries. Then which of the following is false? Here we have to find the false statement. So the options are: A must have real eigenvalue. If the matrix is of 3 cross 3, that is, the characteristic polynomial formed by this matrix is of degree 3. And we know that if the polynomial of degree 3, that is, let A be the matrix, then this polynomial, then its characteristic polynomial is A cube type. And we know that if the polynomial is of A cube type, then its degree will either one real root. So the option is A must have a real root. This is true option. So next, if determinant is equals to 0, then 0 is an eigenvalue of A. We know that for finding the determinant of the matrix, we have to multiply the eigenvalues of the matrix. So if A, B and C is an eigenvalue of matrix of A, then A, B, C is a determinant, and here determinant is equals to 0. So then the product of the values are 0 if one of that value is 0. So 0 must be the eigenvalue of A. So this option is also true. Next, if A is negative and 3 is an eigenvalue, then A must have 3 real eigenvalue. So if one eigenvalue is 3, for option number C, if one eigenvalue is 3, the next eigenvalue here set 3 real eigenvalue. If we take imaginary eigenvalue, and we know that if the eigenvalue is in imaginary, then they are in conjugate pair. So let plus minus iota be the eigenvalue of this. Then to find the determinant of this eigenvalue, this matrix, the determinant is what? Determinant is product of this 3 into iota into minus iota. So what is that? That is 3. So this is positive. So here this is given, determinant of it A is negative. So our example is wrong. We have to take what? Positive eigenvalue, real eigenvalue, not a complex eigenvalue, for negative real root. So this option is also true. And for the third option, last option, determinant of A is positive and 3 is real eigenvalue, then A must have 3 real eigenvalue. So by this example only, we can contradict this statement that we have taken this imaginary eigenvalue and we get the determinant positive. Here this is mentioned that A must have 3 real eigenvalues, which is wrong. So this statement is false. So this is our correct answer. So this is our this is a question based on our knowledge, theoretical knowledge. So this is a solution. If you like this video, then hit the like button, and for more such video you can hit the subscribe button. Thank you for watching.